Let's go ahead and find the factors. So I'm going to write the word factor. The factors of the number 9, let's say. How do you find the factors of the number 9? Well, there's a lot of different ways to do it, but in the beginning here, probably the easiest way to do it is just try to figure out what numbers can be multiplied together to give you a 9. Well, right off the bat, you've got 1 times 9 is equal to 9. And you've also got 3 times 3 is equal to 9. So I don't believe there's any other numbers you can multiply together to give you a 9. Yeah, you could say, here you have 1 times 9. You could flip it around and say 9 times 1, but in the end, it's going to give you the same answer. So the factors that we get are going to be these numbers, 1, 3, and 9. These are the factors of this number. In other words, another way to look at this is these are the only 3 numbers that can be divided into 9 evenly with nothing left over. If you pick another number, 4, 9 divided by 4 doesn't go evenly. Pick another number, 6. 9 divided by 6 doesn't go evenly. So you can do this either way you want. You can try to list everything that can multiply together, or you can just go in your head and start thinking of numbers and see if they divide evenly into your parent number. And if they do, you write them down. All right, so that's it for number 9. Let's look at the number 8. What can be multiplied together to give you 8? Well, you always are going to have 1 times 8. You're going to have 2 times 4. These are both going to be 8, right? And that's about it. I don't think there's anything else that can really do that, that can really be multiplied together to give you 8. Again, you can flip it around and say 4 times 2, but that's not really going to help you. So the factors in this case are 1, 2, 4, and 8. 1, 2, 4, and 8. Again, if you flipped one of these around to say 8 times 1, you would end up listing those numbers as being factors, and so they wouldn't really add to your list. So there's no reason to start listing, 4 times 2 and 8 times 1 because they're going to give you the same exact numbers. So there's really no reason to start flipping things around. You're just trying to find unique numbers. Next number, 7. What can be multiplied together to give you 7? Well, I think there's only one number, or 2 numbers here, that can be multiplied together to give you 7, and that's it, 1 and 7. There's nothing else. So the factors are 1 and 7. Those are the 2 numbers that can be divided evenly into the number 7. What else? Number 4. Let's look at the number 6. What can be multiplied together to give you 6? Well, you have 1 times 6 is equal to 6, and you have 3 times 2 is equal to 6. But there's nothing else. I mean, you could do 2 times 3, but that's not going to really add to your answer. So the factors are 1, 2, 3, and 6. 1, 2, 3, and 6. It's a pretty bulletproof process once you get into it. 3. What about number 3? What can be multiplied together to give you 3? Well, you have 1 times 3 is equal to 3, but there's nothing else. I mean, you can't take anything else and multiply it together to give you 3. So the factors are 1 and 3, and that's it. Let's do something interesting. They might try to trick you in the book and say, well, what about the number 1? What are the factors of number 1? But just take it one step at a time. You realize the only thing you can multiply together to give you 1 is 1. 1 times 1 is 1. So the only factors you have is the number 1. The number 1 is the only number that can be divided into number 1 to give you the answer. So not really a trick question. It's just different. What about 15? Well, you have 1 times 15. You have 3 times 5 is equal to 15. Again, you have 5 times 3, but those are the same numbers. That's not going to help you. So the only factors you have is 1, 3, 5, 15. 1, 3, 5, and 15. All right, let's do another one on this board, and then we'll switch over to the other board. Let's say we have the number 20. Now we start getting into larger numbers. When you get into larger and larger numbers, you're going to have more factors. So let's see, 1 times 20 is equal to 20. We have 4 times 5 is equal to 20. And you have 5 times 4 also, but that's not really going to help you. You also have 2 times 10 is equal to 20. But I don't think there's anything else that you're really going to have. Again, you have 10 times 2 and 5 times 4, but those aren't really going to contribute. So the only factors you really have are 1, 2, 4, 5, 10, and 20. 1, 2, 4, 5, 10, and 20, and that's it. And when you think about it, another way to do this problem, if you didn't want to list all of this out, is you could just start with this number and start going through your numbers and see what is divisible that can go evenly in. Well, 1 can go evenly in, 2 can go evenly in, 4 can go evenly in, and so on and so on. But for instance, 8 cannot go evenly in. There's nothing you can't divide 8 into 20 and get anything even. You're going to get a remainder, and so that's the problem. That's what you don't want. Let's do one more and just kind of broaden it a little bit, make it a little bit difficult for our last one. The number 48. Pretty large number. Now I'm going to tell you right now, if you start trying to go through and multiply everything together that can give you 48, there's a chance that you can miss something. So just do your best and take it one step at a time. 1 times 48 is equal to 48. What else? 2 can be divided in here, and it can go 2 times 24 is also equal to 48. What about the number 3? At first, you might not think the number 3 can go into this, but when you think about it, 3 times 16, if you get a pencil and paper out, you'll figure out that that's also equal to 48. 4 can go in. 4 times 12 is 48. That's just from straight up your multiplication tables. And then 5 can't go in, but 6 can go in. 6 times 8 is 48. All right. Now, again, you can flip these around and say 12 times 4, right? Or 8 times 6 or 16 times 3, but those aren't really going to give you any additional numbers for your factors. So the factors of this guy are 1, 2, 3, 4, 6, 8, 12, 16, 24, and 48. 1, 2, 3, 4, 6, 8, 12, 16, 24, and 48. And again, you need to be careful when you start getting into larger numbers because it's easy to miss one of these combinations. You just do the best you can and start marching up and make sure that you have everything there. And so these numbers, every one of them can be divided evenly into this guy, and that's what we call a factor. Now, before we go on and do a couple of problems with multiples, I want to show you something, sort of a preview. What if I asked you, we're going to do a lot of these kinds of problems later, but what if, instead of a number, what if I said you had some expression like A times B times C? Now, these are letters. Don't worry about the fact that they're letters because all of these letters in algebra, they're just numbers that you don't know the value of. So I don't know what A is equal to. Is A equal to 2 or is A equal to 5? I don't know. So I just put A down. But A, whatever it is multiplied by B, whatever that is multiplied by C, whatever that is. But they're all going to be numbers in the end. I just don't know what they are. So what are the factors of this expression? What are the factors? Factors just mean what can be multiplied together to give you ABC. And the answer is just sort of like staring you at the face, A, comma, B, comma, C, because these things are the only things that can be multiplied together to give you A, B, and C. Another way to look into it, another way to look at it, it's a little bit harder to see here, but it makes sense with the numbers. These guys, A, B, and C, can divide evenly into this guy, and we'll talk about why later, but sort of the easiest way to look at it is the definition of a factor, just like 8 times 6 is 48, so 8 and 6 are both factors. A is multiplied by B is multiplied by C, so by definition all of them have to be factors because they're all able to be multiplied together to give you the final answer. One more really quickly. What about A squared times C? Now we've talked about exponents before in the previous section, so you should know that when you see A squared C, that's just A times C. And I can put my dots in there, that's fine, but I can leave it just like that. This is what the exponent means. A squared is A times A. So when I'm going to write the factors down, I just look and see, well, what's multiplied together to give me what I have? Well, A is multiplied in there, and C is multiplied in there. So those are both factors. These are both factors of this original, what we call an expression. But I guess I'm just giving you a little bit of a preview. So far we've dealt with numbers. I think you're pretty comfortable with making the factors of the numbers. So I'm trying to show you that this stuff is no different than the numbers. With the numbers, we just try to find numbers that can multiply together to give us whatever number we're after, and those are the factors. Here is the algebraic expression These things are the things that can be multiplied together to give me this. These things are the things that can be multiplied together to give me this. So these are the factors. So later on, when we get into more complicated expressions, you'll understand that it's not such a mystical thing because it's the same thing apply to numbers. All right, so what I want to do now is erase the board, and we'll do a couple of problems on multiples. Okay, let's go ahead and do our problems on multiples. They're not going to be very difficult, but you need to prove to yourself that you understand what they are. So what we want to do is we want to write the first 5 multiples of the number given. And so for our first number, we're going to have the number 2. So my question to you is, what are the first 5 multiples? Basically, the easiest way to do multiples, especially if you're doing the first 5, is just count by that number. That's probably the easiest thing to do. So if you're counting by 2s, and you always have to start at 0, you're going to have 0, 2, 4, 6, 8. Now stop, because this is the first 5 multiples. This is the first, second, third, fourth, and fifth. And to just absolutely drill it home, this is 2 times 0. This is 2 times 1. This is 2 times 2. This is 2 times 3. And this is 2 times 4. So this is the, the 5 multiples, because you're just basically taking your base number and multiplying it by a number. So you're getting a multiple. Now let's say you wanted to find the first 5 multiples of the number 3. Well, it's the same thing. You count by 3. So 0, 3, 6, 9, and 12. And that's it. That's the first 5. So you can stop there. And just to absolutely make sure you understand, this is 3 times 0. This is 3 times 1. This is 3 times 2. This is 3 times 3. This is 3 times 4. So each time we're just incrementing and we're multiplying by one more. And so we get the multiples there. Each time we're multiplying by a bigger number, so we get it. What about multiples of 4? Well, we start with 0. We count by 4s. 4. 4 plus 4 gives us 8. 8 plus 4 gives us 12. 12 plus 4 gives us 16. Each time we just add 4 more. So this is 4 multiplied by 0, 4 times 1, 4 times 2, 4 times 3, 4 times 4. Okay? What about multiples of 5? 0, 5, 10, 15, 20. 5 times 0, 5 times 1, 5 times 2, 5 times 3, 5 times 4 is 20. What about multiples of 6? You've got 6 times 0 gives us 0. 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18. 6 times 4 is 24. So you have 0, 6, 12, 18, 24. You're just multiplying by numbers. What about 9? Start with 0. 9 times 0 is 0. 9 times 1 is 9. 9 times 2 is 18. 9 times 3 is 27. 9 times 4 is 36. So you're counting by 9s. And the final one we'll do is an easy one, because we always know how to count by 10s. We start at 0. 10, 20, 30, and 40. So what we have is 10 times 0, 10 times 1, 10 times 2, 10 times 3, 10 times 4. And that is really all it amounts to when you're dealing with multiples. Multiples are going to be useful later on for lots of things, but especially when we start doing fractions and common denominators, and we're doing that with algebra and stuff, we're going to refer to the multiples of an expression or the multiples of a number. And later on, when we're simplifying expressions and solving equations, it's going to be very frequent that you'll factor the expression, or you'll factor the equation. And you'll need to know that what that means is you're looking for something that can divide into that, because that's what a factor is. And that's what we're going to be talking about next. I'm Jason. I hope you've learned something from this section. Not difficult topics, especially when we talk about numbers. Later on, we'll get into their application with equations and expressions. And I hope that you'll see that it's just an extension of this. And if you understand this, then along with the other topics we'll have, you'll get a great foundation and eliminate some of the uncertainty and fear that comes along with pre-algebra, and hopefully you'll see that it's not such a big deal.